Hello, everyone. This is Professor Jeff Wilkerson at Luther College, once again talking to you about what you might see in the night sky. This week, we're going to talk about the week of October 12. But as you know, if you've been following along, these videos apply for a longer time than the 1 week that's out there and give you things to look for over a month or more, maybe sometimes. So anyway, I thought today we would return to the stars of the summer triangle. I've been threatening to do that for a few weeks now, and it seems like maybe this is time. Remember that the stars of the summer triangle are visible right now as we get deep into fall. And for those of us, we're about 43.3 degrees north latitude here at at Decorah at Luther College. And so for those of us here, the two northernmost stars of the summer triangle, we've got Vega and Deneb, and then down to the south, we've got Altair. And so if we go outside just after dark now, let's say 8:30, maybe even a little earlier than 8:30. Right now, these stars are high overhead, and you look south to see Altair. Vega will have passed the meridian. The meridian is the north-south line that passes directly overhead, and Deneb will be very close to the meridian. And for us here, again at 43 degrees north latitude, Vega and Deneb are the two really brightest stars that get closest to the zenith. The zenith is the point that's directly overhead. So we get these stars that if we want to look straight up, we see these stars very close to straight overhead. Now, just after dark, 8:30, right now, as we get into mid-October for us, Deneb has replaced Vega as the star that's closest to the zenith. So you look straight up just after dark if you're in the mid-northern latitudes, and you should see Deneb very, very close to the zenith, to the point that's directly overhead. And so as you watch this go, even though this is called the summer triangle, as you watch this go and we get to the end of the year, you'll watch this settle further and further and further and further to the west. And as it gets dark in December, late December, right into January, you can see these stars, some of these stars at least, hanging on the western horizon. Now, for those of us at mid-northern latitudes, we'll see Altair least. It's far enough south that it will disappear first. It'll disappear below the horizon. The other stars are far enough north that they're very close to being circumpolar. We can almost see them hanging around on the horizon year round, but not quite. They do dip below the horizon. So, a couple interesting things about these stars, and then we'll try to cut it a little short for this week. Just go out, watch this, watch these stars progress, and realize you can see the summer triangle, parts of the summer triangle year round. These stars are all very bright. According to the book that we use for class, Cummins and Kaufman's Discovering the Universe is the book that we're using in class. There's a bright stars table at the back that I often send students to work on work problems or do something. And according to that bright stars table, all three of these stars are among the 20 brightest stars that we see, the 20 brightest stars to our eye in the night sky. And that's pretty good when you consider that there are a couple 100 billion stars in the Milky Way. These stars are among the very brightest. There's not a lot separating them. Vega is listed as the fifth brightest, Altair is the 12th brightest, and Deneb is the 18th brightest. So all of these are very bright stars. Not a lot of difference between them, but a little bit of difference between them. Uh, Stars can appear bright either because they're intrinsically bright, or that means they're glowing, they're really luminous, and they're really pumping out the energy, or because they're close to us, or some combination of the two of those things. And we see all three of these, we see all of these things going on with these three stars. Vega, it turns out, is 25 light years away from us. The galaxy is 100,000 light years across in diameter and its dimensions. So if it's 100,000 light years across, 25 light years is again pretty close. It's a very close star. There aren't a whole lot of stars closer than that. And so if you carve out that volume around us, 25 light years is in there pretty close, and that's one of the reasons Vega seems so bright. But Altair's even closer. Altair's only about 17 light years away from us. So Altair is, Vega's about 1.5 times further away than Altair, but Vega appears brighter. So being further away and yet appearing brighter tells us that Vega is more luminous. So Vega's shining more brightly than Altair is. Now, Altair is an interesting star. At 17 light years, it's one of the closest stars that you can just walk outside and see, and it's an interesting star. It's one of the stars. You know, when I was growing up, when I was in college, we one of the rules was you didn't image the surface of stars. Stars looked like points of light. They weren't resolvable, you would say. You couldn't actually tell what dimension they had. They just looked like pinpoints of light because we didn't have good enough optics to be able to do that. But optics have come a long way. Adaptive optics, taking out the turbulence of the atmosphere and such, come a long way in the last 20 or 30 years. And the result is we can now image the surfaces of some stars. Not a whole lot of stars, but some stars. And Altair is one of those. And so we can see the actual surface of Altair. We see it as an object, not as a pinpoint of light. And it is one of the faster rotating stars. So it is really spinning, so much so when things spin, you know, the Earth here has a bigger diameter at the equator than it does at the poles because of the rotation, the spin of the Earth. Altair, which isn't a solid object like the Earth, and is spinning really rapidly, almost 300 kilometers per second is the velocity of material at the equator, is really flattened. So it's about, I think, 20% bigger at the equator than it is at the pole. So you really notice the flattening of Altair as it rotates around. As I said, it's almost 300 kilometers per second, and gravity wouldn't be strong enough to hold it together if it were as fast as about 400 kilometers per second, roughly speaking. And so it's getting kind of close to the point that it would fling itself apart if it were rotating much more quickly. So Altair is an interesting star that way. Remember, we said Vega is about 25 light years away. Altair's about 17 light years away. Pretty close stars. Deneb, here among the 20 brightest stars in the sky, is 3,200 light years away from us. So it is a long, long ways away. You know, it's more than 100 times further away than the other two stars. So that tells us Deneb is a special star in another kind of way. It's a very luminous star. So it's a luminous giant star, unlike Vega and Altair. So Deneb, remember we said in a video a couple of weeks ago, we said that stars can appear fainter when they're further away, but they also have light being scattered out. That's what we talked about, the sky being blue. And so the further away a star gets, it also is getting dimmer because it's further away. Just like if you look at a flashlight as somebody walks away from you, it looks dimmer and dimmer and dimmer and dimmer. But with the case of stars, there's also more intervening material that's scattering light out to make them look a little bit dimmer. So Deneb is a really luminous star compared to Vega and Altair. Of the bright stars you walk outside and see, it's up there in luminosity and how brightly intrinsically it's shining, how fast it's burning its nuclear fuel to release energy into space. So you go outside for the rest of the year, start this week, and go outside for the rest of the year and watch the stars of the Summer Triangle move to the west. Deneb is very close to the zenith for those of us at mid-northern latitudes right now, and everything's going to be west of the zenith as time progresses the rest of the year. Watch this move over. Think about the difference of the star. Rapidly rotating stars in there, rapidly rotating Altair, really super luminous Deneb, and Vega that's brighter than Altair, but not nearly as bright as Deneb. So enjoy watching the sky, folks. Hope you have clear skies where you are, and hope the fall is going well. We'll have more for you next week. Thank you.